Hi folks, so today what I'm going to be showing you how to create is a D&D dice roller. So we can click on any of these dice and we can get a corresponding roll. What I'm also going to be showing you how to create is global function libraries. So we're going to be able to create this function here where we can input the type of dice. We could even choose advantage or disadvantage or straight roll, the amount of dice to roll, and the result modifier if we had ability scores. And we're going to be using Blueprint macro library and a few Blueprint function libraries to create this so that we can access these functions and macro from anywhere. So let's get started. So first off, we're going to be creating our project. You go into the Games section. As we're creating a new project, click on the blank, give it an appropriate name, and hit Create. Okay, so now we have our project created and open. We're going to create some data for our function, and we're going to create a couple of enumerators and a structure. So if we right click anywhere in the content browser, go up to Blueprint, and here we can create an enumeration or a structure. Let's create a structure first, and I'm going to use the prefix ST for my naming convention. Structure ability scores, and open that up, and we're going to create integers. So I'm going to replicate the D and D rules here for things like strength. Then we're going to have dexterity, constitution, intellect, wisdom, and charisma. And so just go through and rename those. And then once you're done there, hit save and go back into the main window. And now we're going to create an enumeration. So right click in the content browser, Blueprint, and enumeration. So I like to use the prefix enum underscore. And here we're going to have dice types. So in here we're going to create an entry for each of the different dice types. Hit save. And lastly, I'm going to create another enumeration for the type of dice roll. So straight, advantage, or disadvantage. So enum underscore roll type. And 3 entries in here. Hit save. And now that we have these data structures and enumerations created, we are ready to create our global function library. Okay, so let's set up our Blueprint function library. So first thing we're going to do then here is right click in the content browser, go up to Blueprint, and here you'll find Blueprint function library. And the prefix I give to these is BFL underscore, and we're going to have dice roll functions. And if we open that up now, what we should get is, file and save that, this here, and we can have a list of functions down here, and I'm going to rename this. I'm going to call it BFL, Blueprint function library underscore, and we're going to have dice roll. Now we'll be able to call this function here from any other actor in our project. So I'm going to have some inputs here. So the first input I'm going to make is a dice type. And we have our dice types here, enumerator. And I'm going to call this dice type. And Also going to create a roll type. And these are the enumerators we created earlier. And after that, we're going to have amount to roll. That is an integer. And lastly, we're going to have a result modifier. That's just going to add -5 or +5 or +1, whatever it is, as per the D&D rules. So compile and save that. So next up, what we're going to do, we're going to store some of these as variables to make it easier to read. So I'm going to drag off the dice type. I'm going to type select. And this is an interesting node. We can, based on the index, whatever dice type we throw in, we can have a result. But these are wildcards at the moment. So if we right click on return value and change pin type, change that to an integer. And now we can set the value that is output based off of these. And all they're going to do is, this is going to be a D4, D6, D8, 10, 12, and 20. So we're just removing the D, basically, off of those types. And we are going to promote that to a local variable. Now, unfortunately, in Blueprint function libraries, we can't just create a new variable called dice type because it's already here. So we're going to have to come up with a new name for it. So we could say dice type local. And we're going to also store the amount to roll. So promote variable amount to roll local. I always like to keep my blueprints tidy so they're easy to read. So I'm just going to put these as lines. If we just double click on the connectors. And next out, we're going to store the roll type to variable. And this one is going to be called roll type. Save. And last but not least, we're going to store the mod. Tidy up the blueprint again. Result mod local. Brilliant. So after that, we're going to get our roll type. And we're going to switch off of this. And based on the roll type, we're going to produce a different kind of logic based off of these values that we've stored. To do that, we're going to create a few more functions, but we're going to create nested functions. So a function within a function. So we're going to have one for a straight roll, advantage, and disadvantage. So let's create our nested function for a straight roll to begin with. So up here in the functions list, I'm going to create a new function. I'm going to call it BFL underscore nest. So I'm going to call it nest because I'm not going to be calling this function from anywhere else otherwise. And I want a clear distinction in my function names so I don't get confused. And I'm going to call this straight roll. Now from there, I'm going to create two variables, both of them integers. The first, I'm going to call dice type. And the second, I'm going to call amount. So the dice type is going to be this dice type local here, which we've converted from an enumeration into an integer value. So from there, we're going to create a for loop. And I'm going to plug the amount into the last index, and the first index is going to be 1. I'm going to grab off of the dice type. I'm going to type in random integer in range, and that's not going to be connected to the minimum, that's going to be connected to the maximum. Moment. And the minimum value is going to be 1, because the minimum value is the least the dice might roll, and the maximum will be the type of dice. If it was d20, then it would be from 1 to 20, a random number within that range. And from here, I'm going to add, because we might be adding damage. If it was 10 d4s, we would want this to loop 10 times. And then we're going to create a local variable here, plug that into the loop body. We're going to call this result local. And we're going to grab this and add it to itself. And so that should loop through. If it was, say, 10d4, it would loop through 10 times, generating a random number each loop and adding that to itself. And then complete it. We're going to add a return node and add an output there. We're going to call this result and plug result local into that. And so that is our straight roll. Very simple stuff. And so compile, save. We go back into the dice roll function. We can now drag this in and plug it into straight roll. And so we can now drag in our other variables, which we've stored. Dice type local, there and there. And what I'm going to do for the moment, I'm just going to put a print node here and drag the result into that. And very quickly, we're just going to test this out as a function. So in here, I'm just going to create a dummy class. Say it's an actor, BP test actor. I'm going to drag that into the world so that it runs. Open it up. Event graph. We're going to use the event begin play. And then blueprint function library. And here we can see our functions we created without having to create them over here in the functions. So the dice roll is what I want. And let's say I want a single d20 amount to roll plus 1, straight roll because that's the only one that's plugged in, and no results modifier. Compile, save. Hopefully this works. We should see it print off 9. And another 9. A 7. A 1. And these should all be from 1 to 20. So we can see that that's working quite nicely. And what we would actually do here is add a return node. And let's just say result. Plug that in there. And plug result into result. Compile and save that. And now in our test actor, we have a little node here saying result. We'll do it from here instead. We just print that string, plug that into there, compile, save, and there we go. So next I'm going to be showing you how to create the advantage and disadvantage nested functions. A little bit more difficult, and they're very similar to each other. There's just one tiny node in each which changes to give the advantage or disadvantage. So for our advantage roll nested function, I'm going to create a duplicate of this straight roll. I'm just going to rename it advantage roll. And the difference for this one, we're going to use some of this in it because we're still going to be doing the roles. But this time we're going to be doing a few more stages. So this for loop is going to be disconnected from there. Let's disconnect all of these parts here for the moment. So I'm going to store these values here just to make it easier to read the blueprint. So device type local, oh, that's not working. Let's call that one type local, because sometimes working with blueprint function libraries, you'll get issues with naming of variables. So do your best to just type them in to something that you can understand, so that it's easy to read. We're going to store the amount, promote to local variable. This one, once again, might not work. I did good. So create your variables there. And then we can use those throughout the rest of our logic. So we're going to create a 3-part sequence. And this results local, I'm going to call this first roll, because we're going to roll twice for everything and then choose the highest value out of those. So amount local will plug into there. I'm going to get rid of that return node for the moment. And type local is going to go into the max of the random integer in range. And I think that is good as it is there. And for the second sequence, copy and paste all of that. And instead of first roll, we're going to have another variable called second roll. So if we duplicate that, call it second roll. Rearrange my variables. So we're going to set, plug that into there, and second roll goes into there. And so what we've done there then, once again, is to just do the straight roll, but then store that as a value. And then we're going to do another straight roll and store this as a separate value. And then we're going to compare the two. So for the next part, we're going to have an if statement. And we're going to grab our first roll and our second roll. I'm going to say, is that first roll greater than our second roll? And here now we're going to have another value called result local, and based off of that we're going to set the result local to either the first roll or the second roll. And so if the first roll is higher, then we use the first roll. If the second roll is higher, which would be false, then we use the second roll. And from there, we have our return node with our result. And we can just use result local there. And so that is how we do advantage. And disadvantage is similar, except we're going to change this to lower. That's the only difference. So back on our dice roll, we can grab our advantage roll, plug that into there, tidy up our wires. We can add another return node. And one thing we can add now, which I didn't before, was the result mod. So if we grab our result from our function, like add, and just add our result mod local to that. And again, copy these variables and plug them in. And now, in our test actor, let's ask it for an advantage roll of a D20, no results mod. Print the score off. And we should consistently get higher results. So we should be getting average of 14 or 15, I think the math works out at. Doesn't mean we can't get low rolls, but the chance is that they'll be a lot higher, which they seem to be. And we can also put this on a loop, just to make this a little easier. So let's put a small delay in there, say 0.2 is fine, and plug that back into there. So what we're going to be getting is an infinite loop, but separated by a delay, so we won't get any errors. And this will constantly generate for us numbers. And so there, we can start to test various things. Incidentally, if we click on the down arrow on the print string and type anything we like into this key, instead of printing loads of numbers, it will just print one number for us at the top. I keep that constantly changing. Cool. So now let's create our disadvantage node. Or function, sorry. So disadvantage roll. And all I'm going to change in here is that node there. Change that to is less than. And that's it. That's our disadvantage roll made. We just need to plug it in. So let's copy this. Result into there. This into there. Copy our local variables. Plug them in. And that's our disadvantage roll. And just to test that out, let's say we want a disadvantage roll. And press play. And we should be getting a lot of low numbers now, which we see that we are getting quite consistently. And we could test the average number actually in here. So what I'm going to do is I'm going to create an array, promote to variable, just show you a little bit of math we can do here. And I'm going to convert that variable into an array. I'm going to grab our array, and each time we go through the loop, we're going to add the result to an array. And I think we can just get the median of the array from here. And we're going to print that off instead. I'm going to change this number to something a lot smaller. Now we should start to see this averaging out. So on average we'll get 0.7. What this is doing is just printing off the most common number within the array. And if I change this to advantage, we should see oops, it averages out at about 15. And if I just do a straight roll, then we should get 11, I think, because of course dice don't do 0, so it's slightly higher than 10. There it is at 11. So we can always test the math as well, just to make sure that our roll type is working. And if I wanted to add now, let's assume that I wanted to add a +5 to the result. And then we have the +5. It should average out at about 16. It's not quite. But there you have it. And we can say, let's say we wanted to roll 10 d4s with a +5 result mod. And this will give us the average, which would be an average of 30 damage, 29 damage, 30 on average. If we were playing D&D, of course. Or we could just print the results straight out into here. And this would just constantly zoom through tons of numbers. And so there you have it. There is our dice roller mechanic with the functions. Okay, so let's create our Blueprint macro library. Anywhere in the content browser, right-click, go to Blueprint, and Blueprint macro library. I have to create an act for it. So BML underscore. We're going to call this global. So if we wanted to create more macros, we could do. Drag this up here. Now we don't need an execution pin here. It can be purely math. So I'm going to add an integer, and I'm going to call this ability score. And for the output, I'm going to put modifier. So I'm going to clamp the ability score between 0 and 30, as is pretty standard for D&D. And I'm going to type in select. And here we're going to have a massive range of 0 to 30 options. I'm just going to plug this one in first so that we can see we can set, if we have a 0 here, we can get this value out there. So I'm going to fill this in with 30 values and their corresponding modifiers. And there's a lot of them. And so now that we've filled all of these values out, let's give our macro a name so we can find it. So I'm going to call this ML underscore ability score mod as mod. Then back in our test actor, ML underscore as mod. And we simply plug this into here, and whatever ability score we have here will be translated into a results modifier. So compile and save, and there we have it. So next up, I'll be showing you how to create this basic UI with the dice roller functions we've just created. Make it look a little bit more visually appealing, with a bit more pop, a bit more juice, a bit more game feel. So thanks very much, and I'll see you soon.